Huh? It's your call.
To go down the street, no. Like, you know where you got? You keep going down the street and take a right.
Actually, yeah, thanks. You should come to the walk to McDonald's anytime from 4 to 5.
What?
I think there was something on my computer.
This is getting
Like, haha, that's hilarious. And then when it's your family,
one or two. She understands mathematical concepts, but her reasoning. Yeah.
white male. I do not know this. Did I make them out? Yeah, I was like,
Yeah. Here.
What is that?
I can't remember what that one is. What's that one? I can't remember. Is it irrational? I thought it wasn't. Right, it's not.
Not rational. Irrational. No, it's not rational. Irrational. No. That's pretty irrational arguments out there. You have to have two small screws that fit right there.
Yes. I don't have it. I'm serious. I didn't.
Yes.
It's not there. Nothing in me.
Pardon me?
Why did it matter? I didn't do it. My goodness.
I'm sorry. Who just Mr. Myers me? Square root of 729 is 23.
What? It's 27.
Is it?
Yes.
20. Oh, of course it is. 23 would be, yeah. Thank you. That one exists. I think. Don't remember. Yeah. That one's 23, I think. Yeah. I knew 23 was on here somewhere.
Okay, well then yeah.
Yeah.
Hey, boss. Beautiful Atlas. Wow. Here the pond. Hi.
And of course, that takes us to where we are right now. Now, up until now, officially in math class, when faced with a square, an irrational square root, you have all been taught officially to go to your calculator and round it off. That is what you did for every Pythagoras question. That is what you did for every trig question. That is what you always, always, always do. Unless you went through pre-diploma 9 in our school, in which you should have seen what I'm about to show you now. If you didn't, or you forget, of course that's okay, because I'm showing you that right now. So, let us begin. You guys have been taught that the square root of 54 is approximately near between 49 and 64, and it is the 7 and 5 out of 15 steps, which would be 7 and 1/3, which would be approximately 7.33. if you're not allowed to use your calculator. That's what you've been taught up until now. So now we're going to tell you what you're going to do with these numbers for the rest of your life in math class, not in physics or chemistry. This is what we do in math. It's very similar to what we did with pi, and we stopped using the decimals there. We're going to stop using decimals in radicals. And what we are going to do instead is simplify them. Now, again, most of you should have seen this. A radical is an expression containing that symbol somewhere. Now, you notice that I say that symbol because it has more than one meaning. You know it as square root, and now you know it as cube root, but it is also an infinite amount of other roots. You know it as this and this, but it's really that. Any number can go there. An entire radical has no coefficient. So it looks like this. X square root, or X radical Y. Everything's under there. A mixed radical has a coefficient. So it looks like this. Anticlimactic, the usual frozen computer situation. Yes, bum, bum, bum. Surprise, surprise, surprise. That would be wicked awesome. Yeah, I've had enough. I'm not going to take it anymore. It looks like this. A, X, Y. And that A, of course, means that multiplies. Yeah? Yeah. Now, here is what we are going to do to solve this. First of all, you're going to look at that, and of course you know that that is not a rational answer. That is an irrational number. So what we do is we convert that always to the lowest terms mixed radical, which is similar to breaking down ratios and fractions as you have done in the past. So when we are breaking down a fraction or a ratio, how do we do that? We always call it reducing, but of course it isn't reducing because 312 624ths is still a half. It is not reduced in any way. It is still the same amount of pizza. If you cut the pizza into 624 pieces like a doofus and you give away half of it, somebody is getting 312 minuscule slices of pizza. I make that joke because I used to work in a pizza place, and when my friends would order pizza, I would cut the pizza into like 64ths. It was, and then I would deliver it to them. Yes, all the time. They always got mad, but what are they going to do? I'm bringing them their pizza. The other thing I would do is I would put one little section of it and I would dump red pepper flakes on one little section. And then you would cover it and then be covered with cheese and everything. You'd be eating. Oh, you're really good. Ah! And then
Oh, an accident.
huh? They know it was me. We all worked in food. We always did that to each other. Things like that. Anyway. Okay, so what did we do to break down ratios? What did we have to do? We found common factors, yes? Okay, so we know we're going to do stuff with factors here, yes? All right. Now, before we go any further, I need to make you guys aware of a couple of things. Why is this true? What about that equation makes it true? Why do you know that what I wrote there is okay? Lauren? Yeah. So you all do obviously know this. Mr. Hirschman did as good a job as needed to have been done, because Lauren knows that is 3 squared equals 9. And that is really 3 times 3 equals 9. And that is a pair of factors. How did you know you were looking for a pair of factors? Because what number should really be there? A 2. If I were looking for a cubed root from 27, then I would be looking for 3 equal factors, which would be 3 times 3 times 3. So the cubed root of 27 is 3. So what that tells you is you will notice that underneath the radical sign, I broke it down into factors, yes, but specific factors. And those factors were prime numbers. So what we did a little while ago with LCM and GCF, we are now applying to this. So 72 is the square root of 2 cubed times 3 squared. 2 cubed is 8, 3 squared is 9. Yes?
So when we're doing that, we just guess and check?
No, you would make a factor tree. 8 and 9, 2 and 4, 2 and 2, 3 and 3. Prime factors. 2 cubed, 3 squared. Now, because there is no number there, what number should really be there? 2, which means I'm looking for groups of 2. Do I have a group of 2 2s? Yes. So I'm going to bring a 2 out here. Because I'm looking for groups of 2 2, they're coming out as a group. So I only bring out a 2. Are there some 3s there? Yes. So I'm going to bring out how many 3s? 2, but how many do I write? 1, because I'm bringing out a whole group. Now I have 2 numbers in front of a radical sign. They are a coefficient, and coefficients do what? Multiply. So I have 6 root. We don't write the 2. What did I leave under there? A single 2. Most of you should have seen this at one point already. Now, that is the bare minimum that you need to be able to do. There are members of this class that take a very long time to do math. If you choose to do it this way, then you need to get efficient at it. There is another thing you can do if you have done like I told you to do and memorized your perfect squares and cubes. Because of course, your first branch of the factor tree could be 36 and 2, couldn't it? Which would mean that the square root of 72 would be the same thing as the square root of 36 times 2, wouldn't it? And 36 has a square root. What is it? 6. So what would come out? 6, leaving what under there? 2. And you will notice you have the same answer. So anytime you are making your factor trees, you can stop at a perfect square if you are searching for square roots. Now there's a problem with this. A great many of you refuse to pay attention to what you are doing. And somebody asks you for the cubed root of 27, to which you say, 27 is 9 times 3. Square root of 9 is 3. I'm going to bring out a 3. Yeah, buddy. Is that right?
No.
Of course not, because you are not looking for groups of 2 in that case. So you have to be careful. You have to pay attention to your index number. So let us go to this and have a quick look, cabbages. 99, if I am new at this, I might say to myself, I'm going to factor tree 99, and I would go 99, 11, 9, 3, 3. Oh, there's a group of 2. So what will come out? 3, and what will stay under? 11. Now, once you've been doing this for a little while, you of course would stop where? Right there, because that is the cubed root of 9 times 11. What is the square root of 9 times 11? What is the square root of 9? So out will come a 3, and what will stay under there? 11. So once again, I reiterate, you may break down the numbers to prime factors all that you wish, because it will always work. But, as I have also said many, many times, if you choose to use your random access memory, the equivalent of the RAM in a computer, breaking down factors further than you need to, then you are going to risk confuzzling yourself as you get into higher level math. Kind of like saying, I don't need to know my times tables to do math. No, you don't need to, but it sure makes it easier. You also don't need power tools to build a house. But when was the last time you saw a house being built without them? Right? Challenge failed. Okay, you're not Amish.
Well, the house for like a dog.
So you're going to individually screw all the things together and solve.
I'd hammer it. Or I could glue it together, you know, that would work.
This, friends and fans that are not in my classes, is how it goes here.
I just subscribed
Nobody
to your
watches.
channel.
You would
My
be
brother still
surprised.
watches.
You would be very surprised,
My brother
Lauren.
watches occasionally. I come home, he's like watching my walk. I'm like, why are you watching my walk? He's like,
I still think you should put AdSense on your videos.
So,
I don't know if he's listening.
this one, you could break it down for a long ways. For example, you could go 3, 25, 5, 5. There's your group of 2. But of course, you could stop right there because this is 25 times 3. The square root of 25 is 5, and I left a 3 under there. Now, all of you are very good at your times tables up to 12. Some of you get a little dodgy after 12. So, C becomes a bit of an issue because there is indeed a perfect square that goes into 80, but it is past the 12 times table. So, most of you, if I said to do this without a calculator, would probably wholly break down the 80. Right? What would your first most likely breakdown be? 10 and 8. Most likely. 80. Sure. Can't stop there. 2, 5, 2, 4. Can you stop there? Yes. Why?
4 is a square.
4 is the square root. So the square root of 80 is the same as the square root of the square root of the square root of the square root of 2 squared times 4 times 5. Is that a group of 2?
Yeah.
So what comes out?
That.
2. Does that have a square root?
Yeah.
So what comes out? 2. What did I leave there? 5. What do I do with them? 4 root 5. Now, what I was saying, when I do the square root of 80, because I have practiced this significantly more than you, I know that that is 16 times 5. Square root of 16 is 4. There it is, left to 5. Okay?
Okay.
Okay, so what's this guy? I would use 3 and 100, wouldn't you? Why? 100 has a square root. What is it? 10. So what comes out? 10. What did I leave under there? 3. Everybody got it? 63. 7 and 9. Why? Because 9 has a square root. What is it? 3. So what comes out? 3. What stays under there? Yay! 32. Right! 16 times 2. What comes out? 4. What stays under there? 2. What about that one? 3 and 121. What's square root of 121? So what comes out? What stays there? 3. And people say this is difficult. Is it?
She just whispered that this. No, I agree.
Yeah.
Up until like 2 questions ago, I just didn't understand which one you took out.
Yeah, that was my problem.
That has
It's the one that's got a root.
yeah.
Yep. Now, turn the page over. You will want to be aware of how this reverses as well, because later on in math, you may find yourself in such a position as to be able to combine radicals that do not look like they could be combined. One of the ways to do that is to break them down smaller. Another way to do that is to return them to their entire state. So, if there is a single 2 in front, then how big was the group that came out of this situation? 2. So this is really the square root of 5 times 2 squared, which is what? Square root of 20, right? I'm going to write the whole steps there because it's the first one. Yeah? Yeah. If there is a 7 out here, how many 7s were underneath? Times 7 squared, which is 29 times 49, which is... There we go. Okay? Now, I want you to notice something. What do you see there?
Exponent.
An exponent of what? 2. What do you see there?
Exponent of 2.
Excellent. What should you see there?
2.
An index of 2. What should you see there?
Index of 2.
Oh, sorry. There and there.
Index of 2.
Index of 2. 2, index of 2, 2 squared. 7, index of 2, 7 squared. So, x, index of a, y. What would that be? Abso-smurfly correct, young lady. Good job. That would be root of x to the a, y. Okay? So what would this one be? The root of 4 times 6 squared, which would be the root of 4 times 36, which would be the root of 144. Gouda? Great. Now D is tricky. Yes, and we all know how often negatives can mess with your heads.
That's really cool.
I dropped my.
I'm going to take a moment to allow you to talk amongst yourselves while I play with the protractors.
The woo.
Mr. Myers, before this moment really quickly, I just go to the washroom.
Yes.
But I'm supposed to talk to you.
Sam
So,
Sam Schumann.
That's funny.
it's object. I believe that because it is a big. Okay, so run in the opposite direction.
That's how most of you handle negative numbers.
File a report. Please. Believe the negative number. 2D. What do you guys think? Oh, you don't even have your book. Negative 5 squares.
Well, if it's negative 1, then it's going to be 2. Yeah.
12 times negative 5 squares.
What is half?
It's not possible because where do you find the square root of negative numbers? You can't find the square root of a negative number. You cannot find the square root of a negative number.
No, but is it negative 5?
What's the square root of negative 5? No, it's negative 5 times negative 5.
You're right about it.
I think you have
Try to go to 5 negative part of 5, or is it
Five. And we're back. What? Again, I cannot stress this enough to you people. I never give you something that is outside of your concept knowledge. Apply what you already know. What would this be? 5 squared. So you would have the square root of 12 times 5 squared, which would be the square root of 12 times 25, which would be the square root of 300. Correct?
Yeah.
Excellent. Now, what would it be if there was no 5 there? It would be negative the square root of 12, which we know to be 3 something, yes?
Yeah.
So the answer would be negative 3 something. Okay. Well, both of them are there. So what is the only thing I need to add down here to make it the same as here? Negative.
So is the coefficient
Negative is
5 or negative 5?
The coefficient is 5. Another way to look at it is this. Negative 1 times 5. You could rewrite that as negative 1 times 5 root 12. Now that would go back under there as 5 squared.
Yeah, why do you put the negative outside the square root?
What is the square root of negative 49?
Oh, it's not real.
There you go.
In your imagination.
I do love it when you guys answer your own questions. It makes my life so much easier. All right.
That's going on Netflix.
Number 3A. Again, you have all the concepts you need. What must you do to 54? By the way, I think I forgot to tell you what the number 54 is called there. I may have. That makes me a bad math teacher. Over here, please write A. We know that x is a coefficient. We know that a is an index. Y is a radicand.
That sounds like it can be. Like,
For math nerds, if you go to like the engineering section in the UBC bookstore, maybe you would find radicandies.
but they're probably like $150. Get it?
I will tell you that at UVic, the engineers had an intramural hockey team. And rather than having regular numbers on their back like everybody else, they had nerdy science stuff. Like one guy on the team, his name was on his back, name, and instead of a number, he had pi. And another guy had name, and instead of a number, he had the root of -1. He had crap like that. And they thought they were just the coolest. Amazingly, even though they were engineering nerds, they were also the best hockey team. So either they were so nerdy and they went out and found good hockey players to play on their intramural hockey team, or they were actually that good. I will never know. UVic. So,
Well, it's like, I think it was Big Bang Theory or something where they would play
Was
air
it
hockey,
university experience?
and then he would win every
Yes.
single time because he knew the angle.
okay. So, what differs in 3A from what I have been doing in the past?
It's square cube.
I am finding a group of 3. So when I am breaking it down, could I stop at a perfect square? No. So, if I break it down the long way, most of you will probably go 9 and 6. And then probably 3 and 3 and 3 and 2. And there's your group of 3. So what would come out? And what would stay in? And what must I remember to add?
Put a little thing.
An index. Now, if you are getting good at your remembering, you might remember that 54 is 27 times 2. And you might then remember that 27 has a cube root, which is 3. Leaving a 2 under there to get us 3 cube root 2. Now, how will I mess with your heads? I will do things like 3B. Because you will see 144 and say, nah, 12. Nah.
Oh,
But I didn't ask for 12, did I?
you asked.
I asked for the cube root. I am sneaky, aren't I? Of course, the cubed root of 144 is, I don't know. So I break it down. Three. Oops, too many branches there.
That's not 4.
Is there a group of 3 there?
Yes. There's 3, 2, 4.
So what comes out?
2.
2, and what stayed under there?
2.
18.
What times 2?
3 times 3 times 2. Now, if you were good with your times tables, you may say to yourself, self, that is 8 times 18. Now, wait for it. I'm going to give you another trick, Lauren, because that's what I'm here for. You should be noticing that a lot of very small cubes work here, don't they? 8 was the cube root, or the cube of 2. So if you just checked, does 8 go into 144? Goes into that once, leaves 64, 1, 8, 18, 8. Oh, 8 works. Okay. Now, Some of you were saying just yesterday that you were poopy at long division. Not yesterday, that was Sunday. 8 into 144. Quick reminder, 1 sec. 8 does not go into 1. 0. Leaves 0. So you can't do it. But 8 does go into 14 once. 1 times 8 is 8. 14 minus 8 is 6 left over. I had 6 left over. I bring down the 4. Now 8 and 64, 8. 64, 0. Since 8 and 18 work, I can go ahead and use 8 and 18 if my...
But that's it?
Yes. Now,
I'm gonna forget it by tomorrow,
listen to me, please, and then Byron is going to ask a question. If I were you, I would be very comfortable with the first bunch of exponents of 2 and 3. They are very helpful in simplifying radicals. Okay? When I say the first few exponents of 2 and 3, I mean 2, 4, 8, 16, 32, 64, and 128. Up to 2 to the 7th is real helpful. And for 3, I would recommend 3, 9, 27, 81. And 243. 3 up to the 5th. They're real helpful. So let's look at this next one. 128. I said know your 2s and 3s, right?
We don't know.
2's doubled. So 2 to the 6th is 64. Yes?
Yeah.
So 2 to the 7th is 128. Yes?
Yeah.
So this is 2 to the 7th. How many groups of 4 can I get out of there? 1. So out comes a 2. And how many 2's did I leave under there? 3. Would I write it as 2 cubed? Or would I write it as 8? I would write it as 8. Now, Byron, your question.
Yeah, I was wondering if you could do B the long way, because I don't quite...
I did B the long way. That's what this is.
I mean, like, dragging out the exponents and everything, putting them under, like, kind of dragging them out.
1, 2, 3, 4 2's, 3 squared. I need groups of 3. I can only get 1 there, yes? So out comes a 2. And that left 1 2 under there and 3 squared. 2 times 3 squared is 18. Fourth root of 162. Same thing, because isn't that 81 times 2? And isn't 81 9 times 9? And isn't 9 times 9 3 times 3 times 3 times 3? There's your group of 4. 3, fourth root, 2. Again, I say, know the 2's and the 3's. I'm looking for a cube root. So most of the time, I'm going to give you something that you can work with pretty easily. That is 54 times 2, which is 27 times 2 times 2. Does 27 have a cube root? What is it? 3. So what comes out? 3. What stayed under there? 4. How is F different from E? Square root. So can I stop at a cube root?
No, you gotta stop at square root.
I got to stop at a square
9 and
root.
12.
Pardon me?
9 and 12.
9 and 12 work wonderfully. What's the square root of 9?
3.
3. What do I leave under there?
12.
Am I done?
No.
Of course not. Why?
It's 12 plus 5.
12 is 4 times 3. What comes out?
2.
A 2. What's already out there?
3 times
So what do I do?
6.
6 root 3. Yeah?
Yeah.
Yeah. You are going to do 126. Oh, for you it's 123 to 124 to 125. Hey, psst. We aren't on the same page because I'm still hanging. Sarah, why? Why? Sarah, why? Sarah, why? Sarah.
You're out of project. Can't do anything anymore.
Okay. Guys, please remember, I never give you something to do that you do not have the conceptual base for. Do I? So, what would this be? If there was no x squared there, what would it be? 16 times 2, yes?
Yeah.
And if there was no 32 there, what would it be? X times x. So, what's the root of 16?
4.
4. What's the root of x and x? X. What did I leave under there? 2. Right? Okay. You're going to work on P123 to P125, and I'm going to give you your quiz right now. It is all on exponents, and the font is fun and whimsical.
Is that what it's called, or is it
No,
crazy?
the font is actually called...
He has another phone. No, I've done this twice before.
I think this one is Snowfall.
Raindrops.
But it is still full of fun and whimsy.
Jack
Frost.
Huh? Doesn't it just put a smile on your face?
If only it was a snow day.
Nothing's smiling on my face anymore. I'm dead on the inside and
None of you can look me in the eye and say this one is fun or whimsy. That was amazing. What are the chances of that? I could never do that.
Christmas one is the one with the squirrel in the tree. And
I never
it doesn't really matter. Christmas with the Cranks is by far the best Christmas movie of all time.
I didn't watch it.
You've never watched Christmas with the Cranks? It's on Family Channel every year. Sorry, I like Christmas with the Cranks is the best. I like Disney Channel.
First of all, it isn't, because Christmas Vacation is the best Christmas movie.
Thank you. I rest
By
my
a
case.
mile.
I haven't watched either of them.
Mr.
I like
Mr.
Mr.
Myers, what's
Myers.
up with this?
I like Elf.
You'll hand it
I like
in.
Elf.
It's nuclear. I mean, it's
And my apple. No.
No, I like that. What's that show? My glasses. Like every sitcom. No, it was like drama ever. No, they went to like a city. I think it was in the way. Oh yeah.
I agree. You don't
Oh
need
my
to
God.
convince me. Holy crap, Harmon. I almost did it over here too.
Good job. Crazy.
Nuts. Excuse me. when you bring your quiz up for marking purposes, actually, you can hold on to your quiz. We'll mark it together. Who doesn't like porpoises? Crazy people.
Who doesn't like what?
Porpoises.
What are those? Oh, those dolphin thingies?
No. Dolphins are dolphin thingies. Porpoises are different.
Wallet. Porpoises are porpoises.
That's my
It's not anymore.
Wallet.
Keep your quizzes. Bring me the project you marked.
It doesn't have to be the original copy of it.
Bring me the project you marked.
Okay, good. You just say shut up.
I just shut this down.
We will mark these quizzes possibly today, but I doubt it. Somehow, I doubt.